Hey guys, welcome to your Chapter 10 Lesson 4 notes on solving radical equations. By the end of the day, you'll be able to solve equations with radicals and also identify extraneous solutions. So that's going to be a little extra for you. Let's jump right in. You can solve radical equations by squaring each side. Because if you have some expression and you square it like this, that will undo your square root. So let's do this. Remember, you need to first get the variable all by itself. You need to get the radical all by itself. So to undo this minus 5, let's add 5 to both sides. That will give us the square root of a is equal to 3. Now, to undo this square root, we are going to square it. But what you do to one side, you need to do to the other side. So we are going to square both sides of our equation. Now on the left here, the square root and the square are going to cancel out, leaving us with just a. And then 3 squared is 9. Ta-da! So that's super nice. Now we need to check to make sure that that's true. We're going to take our a equals 9 and plug it back into the original square root of a minus 5 equals negative 2. But instead of a, we're going to put 9. Okay. Is it true that the square root of 9, which is 3 minus 5 equals a negative 2? Yeah, that's it. Cool. So a equals 9 totally works. But notice, what did we do at the very end? We checked our work. So you always need to test your solutions. You need to check your solutions to see if they work. Because, let's look at this guy. Oh look, we have 2 square roots. What will undo each of these square roots? You guessed it. Or maybe it didn't, but I believe you did. So you guessed it, square. So the square roots will cancel out on both sides, leaving us with 7b minus 4 equals 5b plus 10. So now that we've gotten rid of the radicals, we can solve this equation like a normal equation. My first step is to get all the variables on the same side. So we make Hamlet proud by going to b, or not to b, that's the joke, minus 4 equals 10. Then to undo that minus 4, we add 4, so we get 2b equals 14. We're almost there. To undo that 2 times b, we'll divide by 2, so we get b equals 7. And now we need to check. Does that make this true? Wow, I made that way too big. Okay. Let's go back to our original equation. Is it true that the square root of 7 times 7 minus 4 equals, the square root of 5 times 7 plus 10? Well, I have news for you. The square root of, that was a minus, 49 minus 4 is equal to the square root of 35 plus 10. Because the square root of 45 is the square root of 45. Super duper. So we plug 7 back in for b. And we got him. Cool. That's fun and all, but when are we going to use this in real life? Well, have you ever seen a clock? You've got this pendulum inside, and he swings back and forth and back and forth. Right? And the time it takes for the pendulum to complete a whole swing is approximated by this equation. 2 times the square root of L over 3.3, where L is the length of the pendulum in feet. Now we know that he completes a full swing in 1 second. Oh, that's super convenient. That means our time, I'll leave that there. That means our time is just 1. Oh, we need to figure out how long is the pendulum. So here we go. The first thing we need to do is we need to undo everything that's happening. So we're going to undo this 2 times by dividing by 2. So we have 1/2 is the square root of L over 3.3. The next thing to undo is the square root. What will undo this square root? Well, let's square it. We need to square both sides. So we get 1/4 equals L divided by 3.3. We're almost there. How can we get L by itself? Well, we need to undo divide by 3.3. So we multiply both sides times 3.3, which gives us 3.3 over 4. Ha ha ha! It's approximately 0.8. So in feet, it's approximately 0.8 feet. That's actually much smaller than I thought. When I think of a grandfather clock, I think of something that's like 6 feet tall. But if the pendulum's not even 1 foot long, this must be a little short guy. It's for like the tabletop or something. Anyway, okay. Let's look at extraneous. If someone is being, oh, I gave it away. Oh, well, you've heard of extra, as in, if someone is being extra, they're going like above, and they can spell above correctly, above and beyond, and that's not always a good thing. There's a movie out about an extraterrestrial, which means someone is from outside of Earth. He's an alien. Or in Spanish, another way to say alien is extranjero. They are outside of this country. They are a foreigner. There you have it. Extra is outside of. It is extra. It's not. It doesn't count. So we call an extraneous solution as one that does not satisfy the original equation. It's outside of the norm, I guess. So let's solve this equation, right? I look at this square root and I want to undo this square root, so I square both sides. Negative c times negative c is a positive c squared. So c squared equals c plus 6. Sweet. I want to set this equal to 0 because it's a quadratic. So I'm going to subtract c and 6 from both sides, which will give me c squared minus c minus 6 equals 0. I can easily factor this guy. That's equal to c minus 3 and c plus 2, because I'm looking for two numbers that multiply to negative 6 and add to negative 1. And that'll get me there. Now I use my zero product property to set each of these factors equal to 0. So if c minus 3 is equal to 0, and c plus 2 is equal to 0, then either c equals 3 or c equals negative 2. So let's find out which one works. So those are our temporary solutions, right? But we have to plug them back into our original equation, which was negative c equals the square root of c plus 6. Wee, 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 wee. Okay. Now let's try them out. Pew, 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 pew. Well, what happens when we plug in positive 3? We get negative 3 equals the square root of 3 plus 6. Guys, you can't take a negative square root. So we just get, that's not a solution. Yeah. Because we'll get negative 3 equals the square root of 9, which is negative 3 equals 3, but that's a no-go. So, sorry, that's not going to work. On the other hand, so we just, nope, not okay. On the other hand, we'll have negative 2 equals the square root of negative 2 plus 6. Is it the case that positive 2 equals the square root of 4? Hey, that totally works. Da, da, da. So there you go, extraneous solution. So we check if it doesn't satisfy it by just plugging it back in. So so satisfy means make true. So we just plug it back into the original equation. Let's find out here. Well, before we square, we need to get the radical all by itself. So I'm going to subtract 6 from both sides. And we get negative rad 2d equals 4. And then we divide by -1. We could have multiplied by -1, but that's the same thing, so whatever. Square root of 2d equals -4. Guys, square roots, not negative. This guy has no solution. I totally solved that differently than my notes. What did I do? Well, spoiler alert, what did I do? Oh, I legit just squared both sides. And I said, okay, well here 2d equals 16, and then I have to divide by 2 to get d equals 8, and then I had to plug it all back in to find out that there was no solution. Oh well. So let's do that. 6 minus the square root of 2d equals 8. No, 10. 6 minus the square root of 16 equals 10. 6 minus 4 is not equal to 10. It's equal to 2. So that is too bad. Not a solution. So this has no solution. And well. So remember that you must, it is essential, it is required, it is important, necessary, that you check your solutions. Otherwise, you'll be left with an extraneous solution, looking like a fool with an extraneous solution. Anyway, have a wonderful time on your homework.